All right, line R5, we're taking a look at learning tasks 1 and 2. We'll do them together inside of a single video because they're both insanely short and they're basically covering the same thing, which is going to be our maintenance and troubleshooting of any of our discharge lighting, whether that's going to be for fluorescence or whether that's going to go and be for my HID lighting. A lot of them are going to be the same. We'll start inside of learning task 1, where it talks about the common points of failure. Things such as a faulty lamp, probably our most common failure. If we're not getting light out, replace the light. If it's not the failed lamp, it's then probably going to go and be a faulty ballast. If it is not the lamp or the ballast, it could be the wiring to that, so absence of supply voltage or low supply voltage, or it could be defective controls that are not giving us the voltage, things like a photocell or something like that. And then last of all, it could just be poor electrical connections as well. Defective controls are out there. They do talk about that it could be a poor photocell. Let's be honest, if a photocell fails, usually that means that the photocell is going to fail on. If you have a light that refuses to shut off, that's indicative of the fact that the photocell has failed. So it's uncommon that's going to be the photocell that's going to go and fail in the off position. Usually that would then be contactors or other components like that. Let's go through our main steps. Step number 1 would be to check by replacing a bulb. Very first thing we always do when we're doing them, replace the bulbs. If the bulb that we put in is a new bulb and it doesn't light, then we're going to go a little bit deeper. We're going to go and check the ballast at that point and make sure that the bulb we put in actually matches. Now, this should be, the first thing that you do. However, sometimes when you get to an installation, you're going to have a customer that says, that light doesn't fix, it doesn't work. So you take out the bulb, and it might have been a T12. You replace it with another T12. It still doesn't light. Then you pull off the ballast cover, and you find out that actually it's supposed to be a T8 or a T. Well, it shouldn't be a T5 because the pins are so small. But maybe it was supposed to be a T8 32 watt, and instead they've got a T12 40 watt, and so it's just not going to go on light. So usually we just, straight up lamp for lamp replace. Sometimes if it doesn't work, double check the ballast. Make sure that the ballast is going to go and match whatever your lamp is. Once again, manufacturer's tables and specifications. If I'm going to be looking at a HID type of fixture, so mercury vapor or metal halide, you can check that you have got voltage at the lamp socket. It should be underneath 1,000 volts. You're going to put it up to your highest scale on your voltmeter, but it should stay below that 1,000 volts. If it is a high pressure sodium, however, you don't want to do that because your high pressure sodium, remember that's those kind of oblong, long bulbs that have got that tube down the center over there, have got that starter. We talked about this when we were talking about the ballast, that it's going to go and create a DC inductive kick. Now, it's not very long. It's going to be anywhere from 1 to generally about 4 milliseconds that we are going to go and get an actual kick out on here. But it is going to be enough of a high value voltage that it can definitely cause some damage to your meter. So be very careful. It's going to be so quick you can't even read it anyways, and it's just going to cause some damage. So make sure you know what your thing is. If you don't have any voltage at the socket, check your line side. If you don't have anything at the line side, then you can go, or if you do have something at the line side, you can go back and double check and make sure that the voltage at the socket is going to go and be high enough as well. And then make sure that the right tap is being utilized. There will be times that you'll run into stuff where, maybe it's a 120 volt supply and somebody has a ballast in there and they've got it hooked up to the 277 or the 347 or something. It's just going to be coming in too low for that thing to actually operate. If it is a cold temperature area inside of any refrigerated areas, like inside of stores where we've got cold storage, or whether it's going to be outside in the winter, make sure that it's actually able to go and ignite. Remember that a lot of our lamps require upon a presence of heat that's going to be generated by their own, or if it's a fluorescent, we need to go and have those cathode preheaters that we are going to go and have. If it's a twin lamp fixture, replace both bulbs. And make sure that, it's not a dead bulb, because if it's a series connection, one of them will be able to take it out. Check the ballast. If you do have a ballast that is refusing to start, you can Megger check it. Now, this is probably not the thing that I would suggest to do, because most of you don't have a Megger with you, nor do you really want to be carrying a Megger up a ladder to a wall pack. But if you take it down, and it doesn't take that long to remove a light fixture if you know what you're doing, take that light fixture down, and then you can Megger it on the ground itself. And then check out your caps. Once again, anytime you're going to be measuring either the ballast or you're going to be checking the caps, you need to go and isolate those components. So if this is my ballast over here where I've got my leads in, leads out, I'm going to go and make sure I know how they're connected. I'll disconnect them, then I'll do the measuring just to make sure that I don't have any shorts to ground inside the ballast. It's usually pretty obvious when you do. The ballast windings themselves are going to be crispy. You know, it's going to be black. You're going to see that little bit of bubbling from where the varnish has actually started to go and boil off inside of there. Capacitors should not be measured. Make sure that those caps are disconnected from the ballast before you do any measuring. And once again, if you are doing measuring, make sure that you've got that thing completely isolated from the line so you don't backfeed it into the rest of your system. Caps, we talked about how to check those, you know, visibly for damage. You're just going to go and see if they've got a bulge on the end. If the casing is bulged at any point, you can probably assume it's going to be a dead cap. Remove that thing, replace it with another. You can, once you have removed them, test them with a proper meter if it has got capacitor test functionality. Okay, that was learning task 1. Learning task 2, we're going to go and talk about, once again, you know, some components in here. Learning task 2 is much more aligned with fluorescent lamps than it is with HID. Learning task 1 had a little bit more to do with that HID. This one's going to be much more with the fluorescence. Once again, if something's not working, substitute a good lamp in. If that lamp does not fix it, then go in and check the ballast. If you have got older ballast, you have to be very careful. Some of those are going to go and be PCB laden. It'll say on the label if it is not PCB. If it's an old tar-filled ballast and it does not say no PCB, make the assumption that it probably has PCBs. Treat it carefully. Wear some gloves, you know, when you're taking that thing down. And then look it up, you know, when you've got a chance, and just verify, you know, what the manufacturers are, whether or not it's going to have PCB content inside of it, and then dispose of it properly, right? If you are going to go and check the open circuit voltage end to end on the lamp, make sure you know what type of lamps you're looking at. If you're dealing with those slimline, which have got that single pin on the end, so we got an end cap that looks like that, and then it's just got a single tab that's going to be sticking out on the end over there. Oftentimes, if that lamp is removed, you won't have any voltage, right? It's got that switch that happens inside of the actual single pin end over there in the tombstone. So you won't get any voltage out of that. Be aware of that. You know, if you're checking the ballast for voltage and there's no voltage over there, it might be because you've got your actual line in, and where it comes into the fixture itself, your line 1 is going to come in and it's going to go through that switch inside of there, and then it goes over to the ballast. So don't just assume you got no voltage in there. You know, double check it and see whether it's switched inside one of the ends. Obviously, if you're checking the ballast, you're probably going to have the lamps out, right? That's the only way to, you know, get at a lot of the ballast covers is to first remove those lamps. If you can check pin to pin. If I've got a bi-pin type of socket, so we'll just move that one there. We'll make this thing a bi-pin. There should be a small differential in voltage that's going to go and cause that current to flow through the heater, which is going to allow us to go and loosen the amalgam and, you know, start emitting electrons off of those things. That shouldn't be a very large value of voltage that you're going to measure from pin to pin. You're usually going to be underneath 10 volts. Sometimes they can be a bit higher, but usually pretty low. Always, before you do any testing, double check what it says on the ballast as well. They will go and tell you the highest OCV. It's very common that we are going to go and see a max OCV or something like that, and that stands for open circuit voltage. It's telling you the maximum voltage that's going to be present anytime that you try to open stuff up. Starters on preheated types of fixtures are going to be these little canisters. They look kind of like a cap, but they're going to go and have a bi-pin that's going to go and have a flare on the end. So if I were to look at them, we'll just modify this thing into one. It's going to be a round little thing that looks like that. The 2 pins that come out of it, in most cases, have got these little rounded, like flat discs that are on the end there. What you do is you stick them into a bi-pin and you have to go and twist them. They're just designed to stay inside there. It's the most common thing on those fixtures that is going to go and fail. That being said, most of our fluorescent fixtures that are old enough to require one of these starters, old enough to just require you ripping that thing out and putting in an electronic ballast. Mismatched components can also cause a lack of, you know, operation, obviously. And then there's a whole set inside of here that gives you a bunch of different lamp symptoms for when they aren't going to go and come on, or ballast symptoms as well. One of the other ones that is not mentioned in here, but that should be mentioned, is just the loss of ground. For some of my fluorescent fixtures, the actual casing requires it to be at ground potential. And that's, I'll just draw a set of tubes over top over here. and then we're going to go and have the actual fixture down below. And then that fixture body is required to be grounded. If that fixture body is not properly bonded down to ground, it actually has trouble creating that arc going all the way across. There's no current that's actually flowing through the body. It just needs to have that tension, that potential difference that it senses, and it gives it an electrostatic, statically induced kick to the actual electrons that are traveling through there. So if you lose that for whatever reason, poor connection, corrosion, etc., these types of fluorescents can go and shut out. Once again, it's an older technology, but it's out there. Double check that the ground bond is properly connected into it. All right, let's go take a quick look through this one over here. If the lamps don't come on, obviously, yes, lamp failure, poor contact in the lamp holder. I don't know how many times I have readjusted, lamps inside of the buy pin. It's very common. People will get one end nailed in, but the other end they have, sitting outside. Double check that. Defective starters on some of them. Ambient temperature too low is going to be a big one for lamps refusing to come on that have operated before. You do need to have cold weather or exterior rated ballast if you're going to be placing them inside of an unheated area. Places like this garage that I'm teaching from right now, it has not gone above -1 all day. I could not operate most fluorescents in here, or if I did, they would be really, really dim. Because even if I get them to start in cold weather, they will often be very, very low. We're going to go and see striations. That's going to be these kind of lines, tiger striping you could call it. That is going to go and happen anytime that we are going to have low temperatures inside. If you have got direct air movement onto it, this also gives us not only a little bit of point cooling on the tubes, but it can also give us electrostatic induction. Once again, where we've got ionized air being moved in a lot of cases, the air that's moved out of the furnace just through triboelectric effects, that's rubbing effects, are going to go and gain, either a positive ionization or a negative ionization. And as a result, when we blow them onto something else, that ionization can affect particularly lamps. So be careful that you don't have anything blowing directly onto them. Once again, the other ones are just defective ones, humming noises, loose assemblies on our fixtures, or a loose ballast that has not been screwed up and they're tight, or it's a defective ballast that is actually starting to go and change. Other times it could be that, it's just a poor ballast, a Class F ballast that has been placed inside of an area that should be like a Class A type of area. We've also got slow starting, where they do start, but it's usually going to be something where it's going to be, once again, problems in the starting circuit. Too low of a value of voltage, or a defective starter that we're going to have, or once again, that cold temperature. If I've got an overheating ballast, high voltage. It's almost every single time that thing has been placed to the wrong value of voltage. Now, most of my electronic ones are going to be 120 to 277. Like, they automatically select that, so we don't worry about that as much these days, but it can happen. It can also happen that I've got defective lamps on my instant start or on my preheated systems. Once again, older styles of fluorescent. Usually, when something is working though, instead of trying to fix up a preheat or an instant start system, we're going to pull the ballast, we're going to replace it with a proper electronic ballast. The can, the casing, a lot of the old fluorescent fixtures, they have far better steel and tombstones than some of the new ones, but we'll just replace that ballast part. Discoloration of the lamps is going to be kind of a purplish or grayish color that you're going to start to get near the ends of the tubes. Usually, this is going to be indicating near end of life. What it is cathode emission. Cathode emission is where the tungstens actually evaporate. Tungsten does that. It gets hot, it evaporates, it's part of our cathode, and then it's going to go and try and build up, usually near the actual cathode that it's part of. If you see it, the thing's just about done. You're pulling fixtures open, you're doing some relamping, take out the ones that are ringed. They're not going to last very long anyways, otherwise it looks like you did a poor job when you're doing your relamping. Mercury accumulation can happen as well. Not as common. Older tubes had higher concentrations of mercury. These days we've got those super high frequencies in our electronic ballast, and as a result of that, we're able to get away with less mercury. We just hit the mercury more times, 20,000 times, rather than 60 times a second, and we get the same amount of light out of it. So I wouldn't say this is something you're going to expect to see, but older tubes, you will sometimes see that. There's heavy grayish stuff. Flip them. Honestly, the mercury is heavy. It's just going to fall down in the other way, but as it starts to release and evaporate and fall through, it's going to give us good light once again for a while. All right, that is it for these self-tests. Oh, last thing, once again, we talked about this before, but take out the extra wire. If you're replacing your ballast, do not leave extra wire in there. It acts as an air core choke, and it is going to screw your lamp capabilities. All right, now we're actually done.